In number 4, we've got square root of 9 minus x squared, so our a squared is 9, which means a is going to be 3. Since we have square root of 9 minus x squared, we're going to use sine for our trig substitution. X equals 3 sine of theta, so dx equals 3 cosine of theta d theta. We can go ahead and substitute those in. We have antiderivative of 3 sine of theta squared over square root of 9 minus 3 sine of theta squared times dx, which is 3 cosine of theta d theta. So we can go ahead and multiply some things out. We end up with 9 sine squared of theta on top. On the bottom, we have square root of 9 minus 9 sine squared of theta. We also have a 3 cosine of theta on top, so I'm going to go ahead and change this to a 27 and add our cosine of theta up there. On the bottom, like recent ones, we can go ahead and factor a 9 out and use our Pythagorean identity. So we get square root of 9 times 1 minus sine squared. But 1 minus sine squared is the same as cosine squared. So we have 27 sine squared of theta, cosine of theta, all over 3 times, remember this is cosine squared, so I'm just going to skip a step there. And square root of cosine squared is just cosine of theta. So our cosine of thetas cancel out. 3 cancel out with this, reduces to 9. So we're left with antiderivative of 9 sine squared of theta d theta. So this is like one that we had last section, sine squared of theta. We can rewrite that. I'm going to pull the 9 outside the integral. And the sine squared I'm going to rewrite as 1 minus cosine of 2 theta. So 1 minus cosine of 2 theta over 2 d theta. So we can bring that half out in front with the 9 also. So we've got 9 halves times antiderivative 1 minus cosine of 2 theta d theta. We can use u substitution here. We can't do the antiderivative cosine of 2 theta without u substitution. So we're going to set u equal to 2 theta. So du is 2 d theta. So we have to multiply the inside by 2, outside by 1/2. So we have 9 fourths times antiderivative of 1 minus cosine of u du. So we have 9 fourths. Antiderivative of 1 is just going to be u. Antiderivative of negative cosine of u, negative sine of u, plus c. So we can replace the u with theta, or u is 2 theta. And then we're going to have to write our final answer in terms of x. So we need to figure out 2 theta and sine of 2 theta from our drawing. So we have theta here. We know x equals 3 sine of theta, so sine of theta equals x over 3. So the opposite side is x. Hypotenuse is 3. Our other side here is going to be square root of 9 minus x squared. So 2 theta, for this part, we have to solve for theta. Theta is going to be the inverse sine of x over 3. So we can substitute that in for theta down here. Then to find sine of 2 theta, we have to use a Pythagorean identity. Or not Pythagorean identity, but a trig identity. Sine of 2 theta is equal to 2 sine of theta cosine of theta. Wouldn't necessarily expect you to remember this off the bat. I won't see this one on your test, but this is what we need to do for this one. So sine of 2 theta is going to be 2 times sine of theta, which we know is x over 3, so 2x over 3, times cosine of theta, adjacent over hypotenuse, so square root of 9 minus x squared over 3. So we end up with 2x square root of 9 minus x squared all over 9 for the sine of 2 theta. So we can substitute those things in here to give our final answer. We have 9/4 times 2 times the inverse sine of x over 3 minus 2x squared root of 9 minus x squared all over 9 plus c.